Ma'am, start. Shall we start?
Yes, ma'am, we can start.
Okay.
We can start.
Okay. Hello.
You are audible, ma'am. Ma'am,
Yes,
you are
ma'am.
audible.
We can hear.
Okay. Okay. Good evening. I am Manohri from CS Department of St. Joseph Institute of Technology, and we are very happy to welcome you all for day one session on data analytics. And we must thank our chairman, directors, principal, and our department head, Dr. Daphne Rose, and Patmakala, Dr. Patmakala, HOD Lab Affairs, for their sustained support in organizing events like this. Finally, I must thank Mr. Ravichandran Madhivanan, one of our distinguished alumni of St. Joseph's College of Engineering, for accepting to share his knowledge on big data analytics. Now, our beloved HOD, Dr. Daphne Rose, will introduce our speaker of today's session. Thank you.
Thank you, Manohri, ma'am, for the warm welcome. Welcome all the participants and the chief guests for this evening session on data analytics. I am very glad to introduce the speaker of the day, Mr. Ravichandran Madhivanan. To speak about Ravichandran, he is a founder of Datapedia. Datapedia is a free online e-learning platform for big data aspirants, which works on the principle that sharing knowledge makes this world a better place. He is the Director of Information Technology for Laila College Alumni Association in Canada. Apart from that, he holds multiple chairs across various non-profit organizations. He currently mentors professionals and students across the world, helping them build their career in the IT industry, and is associated with various organizations like Next Stop Canada, SOPA, that is Settlement Online Pre-Arrival Services, and Ottawa Community Immigrant Services Organization, where he mentors immigrants to Canada from worldwide. Professionally, he works as a data engineer and is a big data expert and has trained many professionals on big data tools and technologies. Also, he has worked in many areas such as front-end development using React, architectural visualization using Lumina, game development, and teaching mathematics. Some of his achievements include uh, chosen for excellence in service dynamics by JVS Toronto. He is also one of the best outgoing students during post-graduation with a state rank and a medal. And he is a social activist and supports multiple NGOs across Chennai as part of his Make a Difference campaign. We are very happy to have you here, sir. Welcome you once again to the session. I hand over the session to you. Now we can start.
Greetings from Canada. Thanks to Dr. Daphne. She saved my time of introducing myself. Thank you, research scholars, students, lecturers, and professors from various departments for connecting to the session. Before going to the session, I would like to make one thing clear, that any content that we discuss here does not relate to any enterprise or organization, and views are personal on behalf of Datapedia.ca. And I would like to tell you all a story. This is not a story of any organization generating reports for making profit or working on data or files or anything, but this is the story of a girl who was molested by her father. This is a story of a teenage guy who was a victim of substance abuse. And this is going to be a story about a girl sitting on her bed with sleeping pills on her desk, trying to commit suicide. You might think what these teenage people have to do with big data. But the fact is that in real world, big data saves a lot of lives, and that's what is happening around the world. So there is this organization called DoSomething.org operating out of the United States. So what do? They are a part of a service organization who provide various services like distributing Valentine's Day cards to elderly people, helping out making peanut butter jars to local pantries. So they started doing social service like this. And that's when they started interacting with people over text messages. So what they found out was quite interesting. They found out that the replies that they got from the text messages were not related to peanut butter jars or Valentine's Day cards, but they received text messages like, I want to commit suicide. As I said, I have a bottle of pills in front of me and I need help. So these were literally text messages from people who were in pain, who needed help. So that's when they started to build a crisis text line for for helping these people in pain. They came up with a big data application that recognizes texts and differentiates it into like normal texts and texts that needed help. So that's how this big data application started. And eventually, they were able to process text messages, and they found out that 30% of the text messages that they received were related to suicides and people who needed help. So for now, they've processed 142 million text messages, and on an average, they save around 2.4 lives per day. And thanks to big data and technology, they were able to do this. For many of us, big data seems like a field where we work on tables. We work on, say, applications that generate reports or that do analysis. But many of us need to understand the need of big data in the real world where it's saving like millions of lives. And this is one such story. So having said that, we'll go into the session. I've planned some hands-on session for you guys. And hopefully I'm planning to do it in an interactive way. So let's go for the session. This session is going to be on big data analytics, and this is the agenda for this session. First, we are going to see an introduction to big data. What is big data and what is the term big data and what is analytics? And we're going to deep dive into the need for big data analytics and some real-time applications that use big data on a day-to-day basis. And we will look into some career aspects and categories of data, how data is categorized into different layers or different types of data, different sources of data. And then we are going to see some big data technologies. I've planned for Sqoop, Hive, and Kafka, some real-time streaming and some batch processing. And finally, we have some introduction to data visualization, and followed by a Q&A session. We're going to leave some questions wide open so that I'll be able to answer them. So looking into what is big data. As the textbook definition says, the data that describes large volumes, data in large volumes is basically big data. But more than that, we need to understand data as something that is beyond the capacity of your system to process, something that resides on a cluster, or something that resides on a cloud, or something that resides on a server. Anything that is beyond the capacity of your system to process can be described as a big data. So with respect to field, big data is a field that uses techniques to analyze systematically and extract information and deal with data sets that are too large or complex. So when we say too large or complex, we mean to differentiate it from the traditional RDBMS system. So when we have data in SQL, it doesn't have the capacity to maintain like large or too large or complex data sets. And that's where the advantage of big data is. And there is a quote by Mr. Vinod Khosla, the co-founder of Sun Microsystems. He stated that big data will replace the need for 80% of all the doctors. And this is in practical working in many heart research centers where they have found out algorithms that replace the need for many of the doctors. What is analytics? The term analytics defines the science of using data or building application models that can help making better decisions and add value to the data. This is a code by Dimitris Bertsimas. Apart from that, analytics is supported by programming languages. Like we have different languages like Python, R, where we use the programming language to do analytics. And we also have some tools to perform analytics such as Cassandra and HTTP, the version of Cloudera. So we have a lot of tools and technologies to make analysis. So what makes analysis interesting is it's not a data that we have, it's like what we do with what we have. That's what is related to analytics. And this term analytics put together with the term big data makes it big data analytics, means we are going to make better decisions by using the data that resides on a cluster or something that is big. And there's a quote, this is one of my favorites: hiding within those mounds of data is the knowledge of that could change the life of a patient or change the world. As we discussed in the story, there are data is doing miracles, it's saving the lives of millions of people. And this is one such quote. Deep diving into what makes data big and why do we need it. And these are the 5 V's when it comes to big data that is important. We need to look into the volume, which means the quantity of data that is created on a day-to-day basis. We're going to see in the subsequent slides of how the volume of data is increasing on a day-to-day basis in the daily life. Velocity, speed at which the data is created. A live example, a real-time example would be the live streaming that is happening now, which means we are transmitting data on from a meeting to a cluster on YouTube, which means the speed at which the data is created is huge and people are able to see it worldwide. The third V as in variety, stands for different forms of data that is created, which means data that is coming in from multiple sources such as RDBMS. We have different relation database management systems such as Sybase, DB2, SQL Server. So variety relates to the different types of data that is coming in from different sources, even text files. The fourth V as in veracity, stands for decisions considering inaccurate data. I have a real-time example of a sample of an inaccurate data that lead to worse results. So veracity is very important when it comes to big data, because the accuracy of data is much more important when it comes to the fifth V, which is V as in value, the results of quality data. So basically the 5 V's, volume, velocity, variety, and veracity, leads to the value, which is in turn is responsible for the results. So what is the demand for big data? As we see, the volume of data that is created worldwide from 2010 to 2025 over the years, and we are estimating to reach it to 50.5 zettabyte 21, which is 1000 power 7 bytes by the year 2020. So how does this increase? How did the volume increase rapidly? So the reason being mobile data traffic, cloud computing traffic. We all use mobile phones on a day-to-day basis. We upload photographs over Instagram. We use photos for uploading in Facebook. So this has led to considerable amount of increase in the data. And also the adoption of technologies, including IoT and AI, which is driving the growth for big data analytics market. And we can see that over 2.5 quintillion bytes of data are generated every day. Quintillion bytes of data is nothing but exabyte, which stands for those who are not sure, it stands for like 1000 to the power 6 bytes. Say when we talk about big data analytics on a day-to-day basis, we have multiple applications that use big data. We have Instagram, like 95 million posts and photos per day. We all use Instagram for posting photos and videos. Is using 95 million photos per day. And we have the New York Stock Exchange, which generates data on a daily basis. It captures 1 TB of trade information during each trading sessions. And we have Facebook, which generates 4 petabytes of data per day. And it includes different sources of data like text, images, we have videos, etc. The fourth one is the one that we were talking about when we talked about V as in veracity in the loss of US economy. It led to 3.1 trillion per year because of poor data quality. For those to understand, a trillion is nothing but a million. So it's $3.1 trillion per year because of the poor data quality. And this is based on the 2019 survey. So before we go into the career aspects, I would like to do a hands-on session on Apache Kafka to understand how it works. Then we could come back to this session on career aspects. So I would like to open up a question on the poll. I'm looking into both YouTube live and the Zoom session. So let's assume that your friend is attending a competition and he's waiting for an answer for say $1,000 question. So, and you're going to help the answers. The question is, who is the first programmer that ever wrote a code? Please post your answers. Meanwhile, I'll connect to the cluster. Okay, I'm seeing messages on the YouTube live. Yes, I'm getting answers from Zoom. Charles Babbage. Dennis Ritchie. Okay. 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 Miss Rena Catherine. So she was the first to answer is Miss Ada Lovelace. So talking a bit about Miss Ada. So she's a mathematician who ever wrote the first program. So let's see how this works. So assume this as a real-time messaging system. Now, the messaging system that we all use on a daily basis and what LinkedIn uses currently. So assume the window on the left that we have here is your text window. And assume the window on the right is your friend's. So let me explain about this concept of Apache Kafka. Seems there is a network issue. So Apache Kafka is one of the big data technologies that is used for real-time streaming. It is a distributed streaming platform, which is used for publish and subscribe as a message queue. As we saw, LinkedIn and other mobile applications use Apache Kafka for real-time streaming, which means when you text someone, it goes through the real-time streaming, and the person on the other end receives your messages through Apache Kafka. So how does this happen? So it stores and processes streams of records on a real-time basis, which means Kafka is going to act as a cluster, and producers here are nothing but the person who is sending the message, and consumers on the other end are people who receive the messages. So this is going to happen through connectors and where producers are able to send messages to the cluster, and the cluster in turn forwards the messages to the consumers. So it's a passage of data between in between the Kafka cluster from the producer to the consumer. And here, producers, as I said, is the person who is sending the message, and consumers are the one who are receiving the messages. So these are the basics of Apache Kafka. It's going to do real-time streaming, and these are some of the commands. Once the session is over, I'll be sharing this presentation with you so that you can work on it with hands-on. So these are some of the Kafka commands that you use on a real-time. And these are some of the terms that Kafka uses. We have Zookeeper, which is a configuration and synchronization service that keeps track of status of the Kafka cluster nodes, and it also keeps track of Kafka topics and partitions. And producers, they publish data to the topics of the choice, which means producers are the one that is sending the messages, and consumers are on the other side are the one those are receiving the messages. So let's talk about the career aspects. These are some of the career aspects when it comes to big data analytics. The first and most important role is the business analyst, the person who is going to have a deep business understanding of what is data, who interacts with the business for making better decisions and predictions with the stakeholders. So the business analyst is the one who is going to work towards the business side. And then comes the data analyst, who understands the data, how data relates to the business, and who is going to collect the data and perform some data analysis and provide the data transformation logics to the data engineer. And data engineer is the person who is going to understand the model. He's going to collect the data from the data analyst and perform data analysis. And he is the person who's going to write the code for transforming data and perform the data validation and deployment of the application. So in few organizations, data analyst and data engineer, the roles are different. So it depends on the organization of how the role is. And finally, we have the BI engineer, who is going to prepare the dashboards for us, and who is going to show all the data that is generated by the data engineer in the form of, say, charts or presentations or visualization graphs, or any thing that is going to prepare a report is prepared by the BI engineer. So these are some of the career level aspects. As a starter, you need not worry about all these. Like, you can start working on your programming languages, and eventually you will find a place in one of these 4 roles in the big data industry. And when it comes to the advanced level, we have the data architects, we have business solution architects, we have the business consultants. So these are advanced level organizations. Categories of, so structured data is nothing but data that has a definite schema, data that has a form or a fixed format. It refers to organized information that can be readily or seamlessly stored and can be accessed from a database. A standard SQL Server or a Sybase or a DB2 can be considered, or any table for that format can be considered as a structured data, as it has data in the form of rows and columns. Unstructured data, this is the data that we deal on a day-to-day basis. We have, let's say, for example, we have Facebook. It has texts, it has videos, it has images, it has data from different formats used on a daily basis. So this is referred to as unstructured data. And finally, we have semi-structured data, which is a combination of structured data and unstructured data, which means it has a definite schema, but does not reside in a relational database on a daily basis. So this is how the data flows through big data layers. We have the source layer, where we have a file, or we have data in the form of a table, and this is the target where we have reports prepared. So how data from a file or from a table is going to become a report. So this is the complete workflow of a big data application system. So with the story that we discussed earlier, we were talking about texts used to analyze risks. There are files that are used to analyze risks. So how does this happen? So files that are in raw format are ingested into the big data system, and it goes through subsequent layers. And the process happens through the data storage layer. We have the data processing layer, we have the data analysis layer, and finally the data access layer. So these layers depend on the requirements. It might change according to the requirements. And finally, from the data access layer, data is fetched up by a report, which is going to make predictions or say decisions on what to do. In the story that we discussed, it is going to take data from a text message, and it's going to process, and it's going to say who is the person who's at high risk and who needs help. And this is the complete flow of the big data system. So when it comes to the data storage layer, we use big data tools such as Sqoop and NiFi to ingest data into the big data system. And then we have the data processing layer, where we use different tools and technologies, such as we use Apache Hive, we use Spark, we use Pig, or different languages and tools for processing data. And finally, we have, before the access layer, we have the analysis layer, where we analyze the incoming data, where we take historical data, where we do some analysis. We include some join conditions and filters, where we analyze the data that we require for the data access layer. And finally, in the data access layer, we are going to prepare data that is going to be provided to the report in an accessible format. So we have different layers in the big data system that is going to perform different operations, and according to the requirements, the layers are going to become different. So these are some of the big data technologies and tools provided by the Apache Foundation. So we have Apache Sqoop. As we discussed, Apache Sqoop is the tool that is going to bring in data from relational database management systems such as SQL Server, and it is going to ingest data into the big data system. So Sqoop is the tool that is going to work on ingesting data from different tables into the big data system. Many of you would have worked on SQL servers and other databases like DB2. So how we bring in data from the different RDBMS to the big data system, it's going to happen through tools like Sqoop. And we call this an ingestion tool because it is performing an ingestion into the big data layer. And then we have Apache Hive, which is going to act as the metastore for processing the information that is brought in by Sqoop. The layers that we discussed in the previous slide, such as data processing layer, data analysis layer, and data access layer. So these are the layers where we use Hive for processing, analyzing, and accessing data and prepare the data for the reporting layer. And the application that we discussed before that was Apache Kafka, where we used it for real-time streaming, say sending in text messages from one person to the other. We have notifications, like say, for example, in LinkedIn, if somebody posts your content, or say somebody sends you a text message, you receive a notification on your mobile that somebody has texted you. So how does this happen? So this is all real-time streaming, and Kafka is one of the widely used real-time streaming technologies in the big data industry. So what is Sqoop? Sqoop is nothing but a command line interface that is used for transferring data between relational database systems. It can perform both import and export, which means you can bring in data from RDBMS to HDFS, which is the big data environment, and you can also export it, which means you can take data from the big data environment and send it to RDBMS. So it works to and fro, Like you can use Sqoop for exporting data and you can Sqoop for importing data. Having said that, HDFS is nothing but Hadoop distributed file system, which acts as the storage for the data that we are going to ingest using Sqoop. And RDBMS, we have different types, SQL, Oracle. So these are some of the Sqoop commands and arguments. So let me share my screen. We'll go through a small hands-on. As we see, I'm using a Cloudera Quick Start VM for this tutorial. So I have provided the links in the document. So once the session is over, you can install this Cloudera Quick Start VM so that you can start working on the big data system. So Quick Start VM is nothing but it provides a complete set of big data tools like Sqoop, Hive, Impala. You can install Spark. You can install many other applications where it creates an environment for you to work on big data. And the good thing is it's open source and it's not licensed. So you can use it for your education purposes. And the advanced version of it is the CDP, the Cloudera Data Platform, but it requires a good amount of infrastructure for the CDH version of Cloudera. If we see the version of Hadoop that I'm using is 2.6.0, and the version of Sqoop that I'm using is 1.4.6. So what is Sqoop? We discussed that it is going to perform some ingestion from different files. So I have downloaded a file for you. You can refer the website called kaggle.com for downloading data sets. So they provide different kinds, like data sets that report football results from 1872 to 2020. So if I go look into this file, so this is the data that is inside this file. So So I've opened the file. If we see, this file contains the date in which the football match happened, and the name of the home team and the name of the away team, the home score, away score, tournaments, where the match happened, city of the match, city where the match happened, city in the country where the match happens, and neutral. Neutral is nothing but specifying did the match happen over in a different place or not. If it's false, which means it happened in one of the home countries or the one of the countries. So this is a data set. So let's see how many records does this data set have. Okay, this data set has the results of 41,587 football matches that happened from 1872 to 2020. This is a very small data set, which is in thousands. I've taken this as an example, but you can consider data sets that are like 40 million, 50 million, where the data is so huge and cannot be handled because of its complexity. It cannot be handled on a relational database management system. And that's where the importance of big data comes into picture. But for demonstration purposes, I've used this data set for explanation. So this is the version of Cloudera Quick Start VM that I was talking about. If we see, it is connected through this address. So let's, Let's give it some time. So if we see, this Cloudera version provides different tools inbuilt. We have Spark, we have Java, we have Pig, we have Hive, we have Impala. All these are tools and technologies in the big data system that we can use. So currently we are focusing on Hive, which is a Metastore. So let's see, I've already created a table called football results. If we see with the schema that we just saw, okay. If we see, I've created all the fields, columns, date, home team, home score, away score, tournament, city, country, and neutral. So these were the columns that were present inside the file. So for demonstration purposes, I'll recreate it again. I'm logging into Hive, which is one of the tools that we discussed and where we're going to work upon. Okay. Let's say I'm creating a table. But let me see what are the databases that are existing inside the current Hive. So we have just one database, which is default, and we can go ahead and use. Okay, so I'm listing the number of tables. So we have two tables, football results and test. And for demo purpose, we are going to create another table. Let's see how this works. Let's say FTP football. Okay. And I'm going to define all the columns. Okay, and then the file that we saw was a CSV file, which means it is in the format of a comma separated file. So I'm going to mention in the table that the file is delimited and the fields are separated by comma. And I'm going to specify the location where I need the table. In our case, the location is a default database. I've specified the location where I need the table, and I'm storing the file as a text file. And since the file has a header, I need to tell the table that I need to skip the header. So if we see, I've just created a table with the following columns, and I've stated the table that it is separated by comma because it's a comma separated file, and I'm storing the table in this particular location. So if you go back to the editor to see the tables that are listed here, previously we had football results and test. But if you refresh, we'll get FTP, Big Data Analytics, Football. And if we see the table is created with the following columns. But when we check the data inside the table, we won't be having any data because we have not loaded data into this. We have just created the table. So let's assume that I'm loading this file into this table. So this is the command for copying a file from a local system on the cluster to the Hadoop environment. I'm telling the system that copy the file, place it in this particular directory, and if the file is already present, just overwrite it and the name of the file. Okay, we have copied the file which had the football results onto the directory where we created the table. So initially the count was 0, but now if we see the count, so if we see now, the number of records have been loaded. It says 41,586 records. So what I basically did now was I had a file which I took from kaggle.com. It is a data set that contained the results of 41,586 football matches, right from 1872 to 2020. The results of the matches, I wanted to bring it into the big data environment for performing some analysis and say predictions or decisions that I want to take. So what I did, I brought the file onto the local system of Hadoop, and from there, I copied it into the cluster. On the cluster, after placing the file, I just created a table on top of it. I actually created the table before placing the file, but it can be done other ways too. Like we can first create the table and then place the file, or you can place the file and you can create a table on top of it. Both ways it is going to work. So now I have brought the file, the data into the big data environment. If you see, okay, let's go ahead and see the data. So this is the data. The date in which the match happened, the home team, the away team, the home score, away score tournaments. So this table exactly contains the data that we saw in the file. So this is the same that works in relational database management system. People already worked on RDBMS might think, what's the difference between bringing the data into Hadoop and bringing it onto an RDB? So in traditional RDBMS, we store data, but we do not make any predictive analysis, or we do not consider the data for making decisions. So that's what is the advantage of big data. So when we bring the data into the big data environment, we have this data to be used for predictions, analysis, wherein we are going to subsequently prepare reports and dashboards on top of it to make better business decisions. So let's assume I'm going to check something. Let's see the different countries where the matches were held. So if I want to do that, I'm just writing a small query here. Many of you who have already worked on SQL would have known this. But when it comes to Hive, it's called HQL, which is Hive Query Language. Okay, meanwhile, the query runs. I want you all to type in some data. Okay, we have the results here. So these are the different countries in which the match was held. We have Afghanistan, it's in alphabetical order. So we have different countries. So I have 100 results. It's displaying the first 100 results. So these are the different countries in which the match was held. Similarly, we can type complex queries, like say, I want to fetch the match that happened only in Afghanistan or Albania. So we get to write different queries here to make the required analysis. And finally, what we do, we produce it on to the big data reporting system where people are able to generate reports on top of it. I'll show you a report. I have it in the subsequent slides. But before that, this is about Hive. So Hive basically is a meta store where we create tables and we store data on Hadoop, and we create tables on top of it to do processing and analysis based on the requirements. But on a complex level, we have advanced queries where we write sort of business rules, we have business conditions. So we make all the decisions and we make predictions on top of it. So that is how it works. So before going into the hands-on for the next session, which is Apache Sqoop, we are just going to do some hands-on with the data that I'm going to collect from you so that it will be interesting for you as well. So just a minute. So this is the table that I'm going to create now. So let's say the name of the table is social media. So let's make a small analysis with the crowd that we have here on Zoom and YouTube. So basically, I want you all to type in something like this. Let's say your name. You can put it in within quotes. Let's say Joseph. And if you're a teacher, maybe you can put T. If you're a student, you can put S. Time spent on Facebook, maybe 30 minutes. Something like okay, no need quote for this because it's an integer. Most favorites, which means if you like watching YouTube more, maybe you can type YouTube. And finally, least favorites, say Instagram. Let's collect some data like this. If you see the screen, you can start typing your inputs. So I'll collect the first 10 inputs from the teachers and from the students, and we are going to create a table. And let's do some analysis, real-time analysis. And I'm going to use Sqoop for that. I'm watching into the YouTube comments as well. So people who are watching on YouTube, you can connect over and you can provide your comments from YouTube as well. So I have this, Mr. Mustaq. He's a teacher and he likes to spend 30 minutes on Facebook, Instagram, YouTube, and WhatsApp. And YouTube is his favorites. Instagram is his least favorites. have Mr. Murugan, who's a teacher. He likes to spend 45 minutes on Facebook, 35 minutes on Instagram, 20 minutes on YouTube, and 30 minutes on WhatsApp. Okay. Okay, we have got like 4 inputs. Okay. Okay, let's go ahead and use this data to ingest using Sqoop. Okay. So this is the version of Sqoop that I'm using. It's 1.4.6. So what I'm going to do now is I'm going to feed this data into traditional RDBMS. Okay. Okay, so these are some of the databases that already exists. So let's use one of these databases. Let's say I'm going to use Metastore. So we have used the database. Okay, so these are some of the tables which are already in the Metastore. So I'm going to create a new table for indexing these 4 records that we just got from the teachers, Mr. Mustak, Murugan, Mano, and Matthew. Okay, so we just created a table. Okay, now select. Okay, so now we have the details of Mr. Mustak, teacher, his time spent on Facebook, Instagram, YouTube, WhatsApp, and his most and least favorite. We'll ingest the other data. Okay, so now we have 4 records, 4 entries in the table, which is the data that we just ingested. And what we did now was a traditional RDBMS. Just imagine the same. Instead of 4 records, we have like 40 lakh records. So this is what we are going to do now. We are going to take this data from a traditional RDBMS system. In our case, it is MySQL Server onto the big data environment. So let's see how we are going to take this data into the big data environment. If we see here, we don't have any tables called social media. So we are just going to create one, Sqoop. If we recall, I was speaking about this technology where we are going to bring in data from a traditional RDBMS system into the big data environment. So this is what we are doing now. We have data inside RDBMS. We have the data about 4 people, Mr. Mustak. I don't recall the other names. So we have the data about 4 people, and we are trying to take the data from RDBMS system into the big data system. This is going to be the same for millions of records. Just assume this is going to be the same. So when it comes to a large scale, the technology and the procedures that we follow are going to be the same, but the number of records is what is going to differ, but the concept is still the same. I'm going to use Sqoop, which is provided by the Apache Foundation to ingest the data onto the big data environment. Since Sqoop is a CLI, which is a command line interface, we cannot execute the Sqoop commands on the Hadoop user interface. I've pasted it just for you to understand. So this is the Sqoop command. Basically, I'm telling Sqoop that I need to import data from a table, and this slash specifies that I have a command in the next line to be executed. So I specify the name of the database and the connection information from where I'm pulling the data. So the database which we used was Metastore, and I'm providing the username and the password, which is provided by Cloudera's CDH version. And I'm specifying the name of the table. Yes, I'm specifying the direct directory. Please note down here something that is more important. If we see the target directory is nothing but it specifies social media. So if we see, it is trying to connect to the MySQL database, and it is executing a query in the background, and it is compiling after connecting to the Hadoop system. So, and it's beginning the import of social media. Remember, we had 4 records in the table. And if we see in the background, there is a map reduce that is executed. So these are advanced level concepts, but as a beginner, I would say that start focusing on writing Sqoop commands, try to import data sets of different kinds from different RDBMS, and try to bring in data to the big data environment. So once you bring the data onto, say, Hadoop, you can perform all the analysis, and you can generate reports on. So it says it has retrieved 4 records, which means that it has pulled 4 records from the MySQL database that we ingested, and it has feeded the 4 records onto the Hadoop system. So where did we place the 4 records? We placed the 4 records in this target directory. So now I'm going to this target directory to see whether the 4 records exist. If we see this directory we just imported contains records in the form of files. So what I need to do is I basically need to build a table on top of these files for the 4 records to show up on the big data system. So what I'm doing is the data which I pulled from the RDBMS, I'm trying to create a table on top of it. So if we see, we have a table called social media FDP. And I'm trying to see the data inside social media FDP. And I see that I have the following 4 records that we just ingested, which is Mano, teacher, and his time spent on Facebook is 0. Interesting. Time spent on Instagram, spent on YouTube, and time spent on WhatsApp. So let's say okay, let's say I want to see who is the person that has spent more time on YouTube. Media, what's, okay, what's the name of the column? Time spent on YouTube. Time spent on YouTube. So I'll give you a recap on what we have done. We took 4 records and we tried ingesting the data into the SQL Server. And after that, we tried bringing in the data from the SQL Server onto the big data system. In real time, we get data in the form of files. We get data from different databases. So basically what we do, we use technology like Sqoop for ingesting the data from different RDBMS and bring it to the Hadoop system. So Sqoop is basically going to work as an ingestion tool for bringing data from different sources into big data environment. And then we have Hive, where we write queries and we make predictions and we do analysis, we do data processing. And finally, we saw Kafka. Kafka is nothing but a real-time streaming. Okay, so here we go. If you order the records, the data based on the time spent on YouTube, okay, it's Mr. Mano who has used least amount of time on YouTube, and it's Mr. Matthew who has spent more time on YouTube. This is just a sample analysis which I'm showing you, but in real-time scenarios, you might have to make better predictions. You might have to include complex logics. You might have to include joins. You might have to include 10 or 12 tables for you to make predictions. So this is just a small prediction from one just table for people to start working on and begin with. So this is about Sqoop and Hive. And going back to the presentation, this is the part of layer that we just worked on. We tried ingesting 4 records of data into the RDBMS, which is the source. And we also saw files, the football results that if you recollect. So we tried ingesting data from different sources such as RDBMS and files into the big data system. And that is, which is called data storage layer. And then we use Hive to do processing analysis and to make all sort of predictions on real scale. And finally, we provide the data in the form of an file or accessible format to the reporting layer, which is going to perform the visualization or dashboards on top of it. So I can show you some real-time reports that was created. So if we see, this is about data visualization. So after we collect and process data, it needs to be visualized, because let's say, for example, I have these 4 records as a table and I can't do anything with it. But if it's a chart or say a diagram or like a report or something like that, it's interesting for the end users to have a look into it, and so that they can make sort of predictions and decisions on top of it. So data needs to be collected and processed. And once it is collected and processed, we need to visualize it to perform exploratory data analysis, which leads to better decisions and predictions. And there are lots of data visualization techniques. There are a lot of tools such as Tableau. We have AtScale, that we have QuickView, we have Plotly, we have different data visualization tools that can be used to visually represent process data in meaningful form. And what is the objective of data visualization? It is mainly to identify areas that represents opportunities for improvements. And as I said, we have, it's going to provide us with a visual summary of information, which makes it easier to identify patterns and trends than looking through thousands of rows on a spreadsheet. Um, let's assume we have 40 million records. And if you take a look into it from a reader's perspective, it's just a table or a spreadsheet. But when you have the data in the form of a graph or a chart, it makes communication easier, data findings easier, the amount of percentage that is going to show. This is the same that we were talking about in the story of a girl who was in pain, who was molested by her father. But how was she helped by the organization? It was just the organization developed a big data application, which was pulling the record from the text message that was sent by her, and it processed all the data using different tools and techniques. Finally, there was a real-time application, a report, or a dashboard that was showing that a girl was needs help, and a trigger, an alarm has to be raised in order to help her. So this is how the end-to-end big data flow works, right from ingesting data and the different steps that it goes through and how it reaches the end user. So if we see here, this is a sample of the raw data. This is real-time data that I fetched from worldometers.info regarding the coronavirus. So this happened like 3 months back during the initial stages of the virus. And if you see, this is just raw data. It's just numbers in the form of rows and columns. It just shows what are the number of cases in different countries, the new cases, the number of deaths, new deaths. So we have different, but with this, someone cannot come to a conclusion of what is the amount of percentage that is differing for a different field. So when I process it using Hive, this is how it looks. This is the similar situation that we just made hands-on. We just worked on hands-on. So if we see, I tried ingesting the data onto the big data environment, and this is how it is processed. Which means if I'm able to pull the records in this particular table, I can see that the records are being fetched, and I have the results of 186 different countries that reported coronavirus during that stage. And this is how it looks on a report. So after all the processing, let's assume this is raw data. From this data, I cannot pull which is the top 5 countries, which are the top 5 countries that got affected by coronavirus. But after processing it through Hive in the big data environment, and when I connect it through to a visualization tool such as Tableau, I'm able to bring a report like this. So one needs to understand that it's not so, it's just the data that is important for visualization. One cannot create a blank dashboard without data. So big data is the important part where we process data, we analyze data, and the visualization is the second part of the system where it is going to use the data that is provided by big data to prepare a report or a dashboard, something like this. So if we see this data, we can see that it shows top 5 countries that that was affected on March 21, 2020. USA, total number of cases, Colombia, India, South Korea, and Australia. So these were the 5 cases. So it's easy for one to understand data when it comes to reports. But how did this all happen? It happened through the processing that on Hive that we discussed. And finally, I have the reported data. So these are the predictions and decisions that I was talking about. If you see, America has reported a 0.14% increase from the previous day. Cambodia has 0.08% increase from the previous day. India with 0.03 and Australia with 0.09. So after all this, I can easily come to a conclusion that America was the country that reported the highest percentage of increase in coronavirus on the next day using the data that was provided by worldometers. So if we see, the ratio is new cases to total cases. So it has the highest amount of percentage, and that's the conclusion I've made from this data set. But if one looks into this data sets, it's difficult for one to say which country has the highest percentage of new cases that got generated on the next day. But this is what the report says. And this is the importance of big data. So I have some of the references listed here. I've used VMware Workstation Player for this, which is an open source. I've used Cloudera Quick Start VM, which is an open source. And I'm using data from kaggle.com, which is an open source dataset website where you get to download all the data sets, such as the one we downloaded, like for the football results. And these are some of the must-read books for the research scholars. We have a book on predictive analytics, the power to predict who will click, buy, lie, or die by Eric Siegel. So this is an excellent book for some scholar who, if you're planning to work on e-commerce, let's say, for example, I'm logging into Amazon site. So when I buy a television, so it immediately gives us a recommendation that I need to buy the TV mount stand as well. So how does this prediction happen? So this prediction is based on the fact that people who buy television will also buy TV mount stand. So this book talks about all the predictive analysis that big companies like Amazon and Flipkart use. So an excellent book for research scholars to work upon. And finally, we have the book, one of the interesting books that I felt is Big Data at Work, Dispelling the Myths, Uncovering the Opportunities by D.H. Davenport. So this book is my personal choice. It unveils the concepts used by different companies such as Google and Facebook, how they use big data and predictions to make better results for the business. We have the Q&A session open. If you have any questions, please feel free to post. I have a few questions here. For those who are requesting for PPTs, after the session, I'll upload it in Datapedia.ca. So you can download it from there. Difference between big data and ML. So big data works mostly on the processing and analysis side, while ML machine learning uses kind of training. You train a system to behave in such a way that it makes predictions. So big data is more on the processing side, while ML, I would say, is mostly based on training systems for better predictions. How large can big data be? Okay, so most of you wouldn't have heard of this word called zettabyte. It's nothing but 1000 to the power 7. So this is the most, the biggest of data that ever exists, and we have almost crossed 50 zettabytes in 2020. And I have even used that in one of my slides. So this is the overall data that is used by, the predictions. But personally, I've worked on data sets that have crossed 40 million, 50 million. So I would say 40 million or 50 million is the amount of records that I've worked on. Data analyst and data engineer difference. Yes, a data analyst would work most on the collecting the data and analyzing the requirements, I would say, and the relationship between data. And data engineer works on producing code, and he's responsible for the deployment. Software needed to work in Windows OS. Okay, so if you have a Windows, you can install VMware Cloud, so which means it'll provide an environment for you, a Linux environment for you to work. So I've used this VMware Workstation Player, which takes you through to Linux, where you install Crowdar VM and use it. Okay, I have a lot of questions. Research areas on big data. That's a very good question. So you can start your research on e-commerce. So that's where most of the predictions and decisions are made. So as I said, this book on predictive analysis can help you on the research topic. Preferable big data sets that can use for research. Where can I get? Okay, you can get your data sets from kaggle.com, Mr. Bala Chodappa. You can get your data sets from kaggle.com. So you have different data sets. Like personally, I've been working on the data set that was provided by NASA. So according to your interest, you can download it and use it. 8 GB of RAM. Yes, Ms. Suhasini, you need to have 8 GB of RAM. We have a lot of questions. Okay. Okay, I think we're running out of time. Okay, what of thanks.
Yeah. Participants, any more questions? Anything to be clear? I think everybody have cleared their doubts. Thank you, Ravichandran, for your wonderful session. Really, it was very interesting session. You took us through various demos, and you took us. We had a very nice period of 2 hours. Very good, informative session. Thank you for sparing your time and sharing your knowledge. And I thank all the participants who have joined today for the FDP. And I would like to say that tomorrow the session starts at 10 o'clock, because today the speaker is from Canada. So we have at this time 5:30 to 7:30. And tomorrow we have a session at 10 o'clock in the morning, and we'll be having on data visualization using Tableau.
Thank you all for joining. And personally, I would like to thank a few more people. I would like to thank Dr. Manohari for for organizing this. I would like to thank Mr. Mola Noor from Canada, Mr. Josh from Nigeria for helping me for this session, and Ms. Jennifer from the US. So thank you all.